皆さんこんにちは。本日はイトリ MSL 2025年次世代スマートモビリティマニュファクチャリングオンラインフォーラムにご参加いただき誠にありがとうございます。本日の司会を務めさせていただきますリュウと申します。ご覧の通り本日のアジェンダでは講師3名がそれぞれのトピックスを紹介します。内容についてご質問がございましたらアンケートの QR コードもしくは概要欄にてリンクにご記入いただければ幸いです。一部のセッションだけ参加される方もぜひご意見やご感想をお聞かせください。ご協力いただけた方に本日のプレゼン資料をお送りいたします。それではオープニングとしてイトリ MSL の楊副社長並びにイトリの日本事務所の楊代表からご挨拶を申し上げます。
Esteemed participants, a warm welcome to today's online forum. My name is Bingxiang Yang, Deputy General Director of Mechanical and Electronic System Research Laboratories, or MMSL, at Industrial Technology Research Institute, or Itri in Taiwan. We are delighted to have you join us as we embark on an exciting journey into the world of intelligent mechatronics and its transformative impacts on manufacturing. Rapid digital transformation, automation, and artificial intelligence are reshaping the manufacturing industry and beyond. They drive faster, more connected, and sustainable operations from factory floors to transportation systems, empowering industry to enhance productivity, efficiency, and safety like never before. Throughout today's forum, we will highlight research and development capabilities dedicated to addressing current industry challenges and advancing flexible manufacturing systems through state-of-the-art technologies. We will see how our intelligent manufacturing and mobility-related technologies make this evolution of the industry possible. I welcome you to ask questions below. Your contributions are invaluable, and we believe that diverse perspectives will lead to innovation and potential collaborations. Before we begin today's agenda, I would like to welcome International Affairs Officer and Representative of Itri Japan, Martin Yang, for a few words.
はい、皆さんこんにちは。イトリ日本事務所所長のヤンマーテンと申します。本日イトリ機械研究所の車両、制御、インテリジェントロボティクスといった分野を中心としたソフトウェアやシステムの応用事例を紹介する本フォーラムにご参加いただきありがとうございます。イトリは6000名以上の職員を擁する世界トップクラスの応用技術研究開発機関です。私どものミッションは技術研究開発によって産業の発展を推進し、経済価値を創造し、社会福祉に貢献することです。私たちは高齢化社会、新しい生産、消費パターン、気候変動など、グローバルな課題に直面する産業界とともに、新たなニーズを見極め、新しい価値を創造することに尽力しております。半導体をはじめ、日本と台湾との協力関係がより一層深まっている今、両国がさらに幅広い領域で長期的な提携を築けることを願っております。今後とも皆様のお力添えをたまりますよう謹んでお願い申し上げます。最後になりますが、本日のイベントが皆さんにとって実り多く新たな協業のきっかけとなることを記念し、私からの挨拶とさせていただきます。ありがとうございます。
楊副社長と楊代表、ありがとうございました。続いては楊副所長による機械研究所の前哨紹介に移らせていただきます。
Hello, my name is Bingxiang Yang from Mechanical and Electronic System Research Labs, or MMSL, at Industrial Technology Research Institute, or Itri in Taiwan. In this presentation, I am going to give you a quick overview on the capabilities of enabling future smart manufacturing and vehicle technologies. MMSL consists of more than 500 employees, with the majority of them are researchers with master or doctoral degrees. We have more than 1,500 active patents. Our aim is to provide technologies to enhance the intelligence, precision, and green for the industry. We have two major areas. One is intelligent manufacturing, covering robotics, intelligent factories, and also key modules or equipment for the semiconductor industry, and green technologies for different types of industries. The other one is for intelligent mobility. We develop electric and new energy vehicles, autonomous driving technologies, unmanned aerial vehicles, and also railway systems. For the intelligent factory, so we try to connect equipment and materials together with Internet of Things. We also have sensors integrate with our algorithm to quantify the status of the equipment. Then we can connect the equipment together with the parameters. And we also incorporate AI technologies in different stages of manufacturing to control the quality of the product. To integrate all of this, that we can have the manufacturing process smarter. Here is an example. Now we try to integrate systems. As a world trend of low carbon or zero carbon emission, we try to reduce the energy consumption in different manufacturing processes with different strategies. The first one is to provide high efficient motors that can be used in different stages of manufacturing, and also low carbon thermal management systems with the energy storage applications, also such as the high-speed flywheel technologies and also superconductor technologies. We also developed new low-carbon, high-efficiency manufacturing processes. Here is an example.
Sinmat microwave annealing technology is the result of a tripartite collaboration between Itri, National Jiao Tong University, and National Nano Device Laboratories. Can process multiple wafers at one time and can effectively control the heating range to avoid thermal diffusion. The technology saves a great deal of time and energy compared to rapid thermal annealing. The frequency of the microwave tubes used in the new technology is 2.45 gigahertz, the same as that of a typical domestic microwave oven. A 2.45 gigahertz magnetron costs only about 1/10 of the price of the 5.8 gigahertz high-frequency microwave magnetron currently used by manufacturers, while its average lifetime is 6 times longer, which greatly reduces maintenance costs.
As you might know that Taiwan is famous about semiconductor manufacturing, we also have a division dedicated to these technologies. So we use multi-physics simulation in different stages of the manufacturing process, such as the plasma etching or deposition and wave process for advanced packaging. And we also provide grinding polishing equipment that can be used in different materials, including the optical components. We also integrate low fluoride or low carbon equipment in different industries for green technologies.
The following is the principle of the hybrid ALD equipment. The vertical flow field is simulated by multiple physical coupling methods into the 12-inch process chamber through the aeration module, and the special aeration hole design is used to improve the uniformity of the overall chamber flow field. Place the cassette into the wafer loader. System parameter confirmation. By adopting the crossover flow multimodal ALD technology, the thermolysis and plasma bias dual mode is used to enhance the collimation of deep hole coatings, thereby improving the compactness and deposition selectivity of the film layer, achieving multi-composition, high-step coverage, and uniform coating deposition. The robot arm removes the wafer from the process chamber and transfers it to the discharge chamber.
To combine the different manufacturing processes, we need robotic technologies. Over the past 20 years, now we have developed different types of service robotics, industrial robots, AGV, AMRs. We also apply that into different fields, including the surgical fields. We recently have international collaborations with many European countries on the handling with AI-enhanced robotic technologies for flexible manufacturing. That's for manufacturing. Now for mobility, now we developed technologies to fulfill the needs for electric vehicles, from fast charging station, onboard charger, battery pack, energy management systems, vehicle control units, even inverter and motors. So we work with industrial partners to develop the whole system. We are also the first team to have the driving license to drive our autonomous driving vehicles on the real road. Now we have different types of autonomous driving vehicles. We also export these technologies to international partners, such as in Japan. Now we have high-definition map technologies. And in Australia, we now can drive a 35-ton truck on the highway in Australia. As for ground vehicles, in the air, now we also have unmanned aerial vehicles. We target more on the high payload, specific application, UAVs. Over the past few years, we have developed flight control technologies, high power motor generating technologies, and also integrate into the system with different payloads and applications. In many developed countries, railroad transportation is a good means to transport from one place to another. So we have helped our railroad companies to develop BRT tester, platform screen doors, also intelligent inspection vehicles for railroad track, and automatic painting factories. So we target more on the operational or maintenance systems for railroad transportation. So with this, I give you a quick overview of our capabilities. So if you are interested in any of the technology, feel free to contact us. Thank you.
楊副所長、ありがとうございました。機械研究所の全貌がよくわかり、皆様の今後の研究がますます楽しみになりました。それでは最初の講師、馬さんからは、車両モータードライブコントローラー技術についてお話しいただきます。
Hello everyone, I'm Umashankar Raut, a hardware engineer at ITRI Mechanical and Mechatronics System Research Lab. Today I am excited to share how our advanced motor controller technology powered by silicon carbide or SiC are reshaping the future of electric mobility. In the next few minutes, I will walk through our journey of compressing kilowatts into liters, minimizing energy losses, and accelerating time to market for our partners. Let's start by looking at our roadmaps that making 100 kilowatt liter per power density a real possibility in 2025. Here you see the complete EV powertrain. The charger brings the grid power, the battery stores that energy, and motor controller convert DC to controlled AC to drive the motors. The motor controller is what our team focused on. In 2020, our inverter achieved 20 kilowatt power density. By 2023, we improved that to 60 kilowatt per liter using SiC technology, better thermal design, and optimized layout. Our next goal is 100 kilowatt per liter by 2025. We are making it happen by using next generation silicon carbide devices, replacing film capacitor with high density ceramic ones, adopting compact liquid cooling systems, and integrating PCB based Rogowski coil for current sensing. This results in smaller, lighter inverter, freeing space, reducing weight, and improving vehicle range. Even better, our design scales seamlessly from 6 kilowatt to 250 kilowatt, enabling adoption across e-scooter, sedan, truck, and buses. Now, let me take behind the scene how we make sure every motor controllers work right the first time. We begin with detailed 3D multiphysics simulation to analyze the heat magnetic flux and electrical stress. We tweak the design until it meets thermal and loss limits. Next, we built the prototype and run the double pulse test to access the switching losses and voltage overshoot in real circuits. In hardware in loop testing, we connect the controller to real-time simulator emulating a motor. This allows us to run thousands of fault cases safely and efficiently. In vehicle dyno testing, finally the controller is mounted on real vehicle in our dyno lab to evaluate the efficiency map, acoustic noise, thermal rise, and system response during the actual drive cycles. Each stage helps us catch potential issues early, reducing prototype iteration, saving times, and cutting costs. Quality is our promise. We operate 4 specialized labs, virtual vehicle labs, validate the control algorithm across millions of virtual kilometers. Power labs measures efficiency, EMI, and transient voltage behavior. Battery and charger lab ensure communication reliability across chargers, BMS, and environmental extremes. Vehicle lab execute complete vehicle validation, vibration, splash water, dust, and shock. We also follow a strict pre-test checklist, cable torques, sensor calibration, emergency stop mechanism, proper fuse settings. For endurance, we test the inverter at 85 degrees Celsius for hours, subject them to hours of multi-axis vibration, access corrosion in salty spray chambers. Thanks to this rigorous process, our field failure rate is too low, ensuring low recalls, longer uptimes, and happier drivers. We follow modular design philosophy. Power module blocks contain SiC switches, DC bus block integrate high density ceramic capacitors, gate driver blocks control each switches precisely, control board execute the advanced motor controller algorithms. This block based approach allows us to serve multiple vehicle classes from 6 kilowatt scooters to 250 kilowatt heavy duty trucks, all using the same scalable architecture. Our firmware is equally flexible. It auto detects input condition and scales control gains automatically. This results in faster development for OEMs, lower the BOM costs through parts reuse, simplified maintenance, one code based support multiple vehicle types. To conclude, what you have seen today is a journey of engineering precision. We have combined SiC technology, compact power design, and rigorous validation to deliver compact, reliable, and scalable motor controller solution for EV industry. We welcome partners ready to join us in pushing the boundaries of what electric vehicle can achieve. Thank you for your attention. I'm open for the question now or happy to discuss detail with you after the session.
馬さん、 大変興味深いお話ありがとうございます。続きまして講師の張さんは多用途ドローンについてお話しいただきます。
Hello everyone, I'm Alan, a member of the UAV divisions at the Mechanical Mechatronic Systems Research Laboratory. And today I was excited to share with you some of our recent UAV solutions, especially for our multiple-purpose UAV solutions. And now let's dive into the core topics of these presentations. And this system we developed is called the XA drones, which is fully developed by Itri. It integrates all key components, including airframe design, propulsion designs, flight control systems, and the communication modules. And in particular, the propulsion system feature is the high thrust ratio brushless motor and the electric speed controller, which is developed by ourselves, and we do the technical transfer to the Taiwan local company to do the mass productions. So this technology, this multi-mission UAV platform is designed to support a wide range of applications, such as the logistic delivery and the power line inspection and the water quality adaptings. It also have the significant feature is quickly folding mechanism and the automatic flight routes planning by itself. Okay. And next, I will walk you through how this solution has been applied successfully across various fields. Okay, so from the left to right, here are three key application scenarios of the XA drones. You can see the left-hand side is logistics deliveries. The XA drones enabled efficiency to transport of goods to destination locations. And the key benefit is reduce the labor cost and improves the delivery efficiency. And the center of this picture is the power line inspection applications. And we developed and using the AI-based image recognitions. So the drone can accurately detect the position and the temperature of high voltage power lines to identify how damaging or overheating problems. So the key benefit is greatly shortened inspection time and able to early detection of the faults and allows for timely maintenance, which is reducing overall operational costs. And the final is the right-hand side pictures was the water quality adapting applications. Traditionally, sampling water in larger reservoirs require a lot of labor efforts, which was time-consuming and inefficient. However, with the drones, the water samples can now be collected rapidly and accurately. So the key benefit of this scenario is minimize the manpower needed and accelerate data collection and improve the overall efficiency of the water quality adaptings. Okay, so this section's highlights is a key insight from the drone industry, the marketing. So we can show this slide. Nearly 80% of the total marketing value is now concentrated in the UAV application service, rather than hardware or software, etc. So this shows a clear shift is the real value of the drone today is like how they are applied. So our multi-mission drone solution is designed precisely for this high-value segment. So its target is practically deployed in areas such as logistics delivery and infrastructure inspection or public military service missions to ensuring the UAV technology delivery real-world impact and value. Okay, and next, I'd like to share the real successful cases. This case is as shown in the slide. We integrate the XA drone into the logistics delivery applications, and we cooperate with the Japan's companies, which name is the Tonplus. And this company is focused on the logistic technologies. So we conduct the conduct and the integration of drone for delivery application and to do the validation in the Kobe port and the Netaria headquarters campus. So this cooperation is not only demonstrate the missions, but also serves as a strategy step towards entering the Japanese markets. And here are another successful case of collaboration with the Japanese companies. The name is Sensor Robotics. It was a leading drone solution provider in Japan. In these cases, we integrate our XA drone system with the Sensor Robotics power lines recognition modules and conduct the joint field tests in the Japan. And the goal of this collaboration is to build the fully integration power line inspection solutions, paving the way for deploying in the Japan's infrastructure's inspection marketing. Okay. And lastly, we'd like to share another successful case. Was this time in collaboration with the water quality adapting. And we equipped the XA drone with the system of the harvesting the water's adaptings and performed a live demonstration at the Sun Moon Lake in Nantou, Taiwan. And compared to traditional manual samplings, the drone-based solution reduced operating time by over 80% and significantly lower than needed for manpower. So these cases highlight the strong potential of the UAV in the environment monitoring or adapting, especially for fast, large-scale water assembly operations.
張さん、技術を分かりやすくご説明いただきありがとうございます。続きまして、講師のラさんは、HolonOS AI センサー、制御を統合したロボット用コアソフトウェアについてお話しいただきます。
Imagine a future where the robot is not just a tool, but an intelligent partner, one entity that can continuously learning and self-evolving. Hi, I'm YC, the CEO and founder of HolonOS. We are building the first AI robotic software capable of standalone intelligence and unified knowledge. HolonOS is a software company. We preserve industrial knowledge through AI. We preserve manufacturing knowledge through automation by unifying AI, robot, and sensors, making intelligent manufacturing a reality. We have 7 experts across robotics R&D, finance, marketing, and operation, combining technical depth with business execution. After 4 years incubate in Itri, we are officially spin off this year and close 0.5 million angel round. As labor shortage is serious and happen around the world, in manufacturing, company lost up to 10 million revenue when their senior engineer retire or exit. In metal processing, it's much more urgent. The median worker age is 51, the highest among 80 other industries. So, After 30 years automation, what holding it back? 3 reasons. Industrial robot has been limited to mass production, requiring specialized expertise, complex programming, and manual adjustment. First, hard to learn. Manufacturers need to at least 2 years to train a robotics engineer, making skilled labor a major barrier. It's especially difficult because we are facing labor shortage issue. Once they leave, the knowledge goes them. Second, time-consuming. Developing, testing, and validating a robotics automation project take 3 to 6 months to ensure production feasibility, making the process highly time-consuming. Third, rigid. Even after deploying the robotics automation in production, every changeover needs manual reteaching and adjustment. The knowledge is hard to transfer, making robotics hard to use in today's fast-changing manufacturing need. So, we envision the robots not as a tool, but an intelligent, self-evolved partner. That's why we built an AI-driven operating software with a human-in-the-loop approach. It allows the robot to learn directly from the operators and turn the experience into intelligence. We make robots that don't just do tasks, they understand how to do tasks. To do that, we simplify the process to save 85% of the time. Meanwhile, our solution can continuously learn from the operator's experience. Eventually, will lead to 30% boost in productivity. To achieve these 2 goals, we designed two products for each purpose. We built 2 integrated products, HolonOS and HolonCloud. The idea is like iOS and iCloud work together. HolonOS, control panel, a complete hardware and software solution designed for instant execution and rapid response for robots and sensors. HolonCloud, a cloud-based platform for deep learning and centralized intelligence, enhanced AI-driven for robotics and sensor. HolonOS, an edge AI control panel featured with, first, unified interface. It eliminating the sensor and robot integration time. Supports leading robot brands like Fanuc, ABB, Yaskawa, KUKA, and Mitsubishi. It integrates 2D vision, 3D vision, laser line scanning for sensor, active force control, PLC, and I/O modules, all to saving the integration time. Second, cat-free patch generation engine with just 3 simple steps: scan, patch generation, and deploy. Simply place the workpiece and the 3D scan automatically sensing its geometry. User can interactively adjust and generate the robot path. Seamlessly deploy in a unified interface, eliminating the needs for CAD model or manual teaching. Last, an edge AI. That's how our HolonOS can learn and improve direct from the first-hand data, based on any operator intervention that make the robot actually learn from the human. HolonCloud, a deep thinking and learning service AI code generation. Generate the robot code from the process idea in minutes, saving programming time. It creates accurate robot program based on process requirements. And it also acts as an AI assistant, answering technical questions instantly. It's embedded with system knowledge, including maintenance manual, operation guides, mechanical and electrical diagram, ensuring precision and efficient support, saving the troubleshooting time. Our go-to-market strategy is simple and clear. We direct bring value to the end user to save time and increase productivity. Collaborate with system integrators to accelerate the deploy and amplify the word to mouth. Once we achieve the product market fit, we will scale through distributors and key suppliers to build a global sales network and scale rapidly. Today, Holon Robotics has delivered 15 successful cases across 9 industries, with $800,000 in revenue, which are medical, cutlery, defense and grinding, one of the largest cutlery, heavy machinery manufacturers, and kitchenware company. Also, we co-marketing with industrial leaders, including Fanuc, Mitsubishi, Neurosys, and the NVIDIA In-Session program. One of our success story is in cutlery industry. Changeover in cutlery manufacturers are a real headache. Parts are never perfect. Usually, means tedious manual adjustment because of an avoidable preprocessed workpiece difference. HolonOS, paired with a laser line scanner, it will automatically measure each workpiece geometry and generate exact grinding path to removing the setup time. Now, customer can swap between 50 plus product types on the same line and already process over 300,000 parts with 30% of a productivity increase. Same issue happened in the motorcycle and fitness bike industry. The unavoidable preprocessed workpiece difference, HolonOS, with a laser line scanning, capture each part's dimension and auto-generate precision grinding and polishing path, cutting setup time to minutes. The intuitive parameter interface that can turn complex adjustment into a few clicks, ensuring smooth production and consistent quality. So if you're excited about a future that robots should not just be a tool, it's actually an intelligent partner, we love to connect.
ラさん、HolonOS AI センサー、制御を統合したロボット用コアソフトウェアを理解やすくご説明いただき、誠にありがとうございます。最後に、クロージングとして、イトリ MSL 洋服社長から閉会のご挨拶を申し上げます。
As today's forum concludes, I thank you for being a part of this deeply insightful and enlightening online forum. Our collective passion for innovation and dedication to reshaping the future manufacturing and mobility have made this an exceptional exchange. That this forum serves as a stepping stone towards forging new partnerships, fostering innovation, and nurturing the growth of intelligent mechatronics in the manufacturing and mobility sectors. I encourage you to stay connected, continue to exchange ideas, and explore opportunities to collaborate. Once again, thank you for your active participation, and I look forward to meeting you again in the future.
以上をもちまして、イトリ MSL 2025年次世代スマートモビリティマニュファクチャリングオンラインフォーラムを終了とさせていただきます。最後までご参加いただき、誠にありがとうございました。アンケートの QR コードにご記入いただければ幸いです。皆さんからのフィードバックを以降のフォーラムに生かしてまいりますので、ぜひご協力くださいませ。忌憚のないご意見をお待ちしております。ご参加いただき、改めてお礼を申し上げます。